Last time we talked about the method of Lagrange multipliers, and I want to make sure you're comfortable doing that. So we should do a problem that's more in line with what you'd see on a typical exam. I feel that this captures what would be more in line with what you might see on a typical exam. It is from an exam. I think it's from the final exam. Yes, final exam, fall 2019. So the problem. Use the method of Lagrange multipliers to find the maximum and minimum values of f of xy equals y minus x, given that x squared plus 2xy plus 3y squared equals 3. Now, here's the thing. If they ask you to find the max and min, just trust that they know what they're asking for. The method of Lagrange multipliers does not have a built-in, this is a max or this is a min. So just go through the process. The key here is you're finding places where max and mins can occur. You test them, and you say, okay, I'm not going to worry about whether or not it's a proper max or min. I'm just going to trust. Now, it's not hard for us to trust in this case. This turns out to be, this turns out to be an ellipse. So, you've had a few minutes. Does somebody have an answer? Or there's really two answers. Oh, there's a lot of hands. Well, how about in the back? Yes.
For max, 3 and then -3.
Okay, 3 and -3. Any similar answers? Yes. Yes. Okay, so the answers. Max is 3, min is -3. But it's not the answers that matter. It's the journey. All right, so let's go through the process. Now, sometimes they're very blunt. And I think on our exams, I tend to like to be blunt with students. Lagrange multipliers, so they're just telling us right away what method to use. But if they hadn't told us right away that it was Lagrange multipliers, what's a clue that it's Lagrange multipliers? There's a constraint. So if you have this sort of extra thing, like there's two formulas, something you're trying to optimize, and then there's this other formula with an equal sign, that's Lagrange multipliers. So we have our optimize, f of xy equals y minus x, our constraint given g of xy, which is x squared plus 2xy plus 3y squared equals 3. Very rarely will they do something sneaky like put variables on both sides. If they put variables on both sides, move everything to one side. All right. So, what's the plan? The plan is we have to solve for points. So we have two variables, x and y. We need two equations. Good news is we have one equation, the constraint. So that's one equation. So we'll put that down here. But we need to get a second equation, a second relationship that's satisfied. So how do we find that second relationship? Gradient. Specifically how?
The grade of x equals lambda times the gradient of g.
Yes. So our second relationship is coming from this formula. So our first relationship was our constraint. Our second relationship is going to come from here. Now, this is actually a couple of formulas packed together. It says fx is lambda gx and fy is lambda gy. Just setting the corresponding entries equal to each other. What is f sub x? -1. What is g sub x? 2x plus 2y. What is f sub y? 1. Equals lambda. What is g sub y? 2x plus 6y. Now, I encourage you to solve for lambda. There's other ways to do it, but essentially it ends up being the same. So lambda is -1 over 2x plus 2y, but it's also equal to +1 over 2x plus 6y. And from here, if you cross multiply, because fractions are scary, then we don't have to worry about fractions. we'll get minus 2x minus 6y. Right, that's the minus 1 times 2x plus 6y is equal to positive 2x plus 2y. Well, we're almost there. We move terms around. And if we do that, we'll get minus, no, 8y. I can do math, right, because we subtract 2y. Minus 8y equals positive 4x, or x equals negative 2y. So that's our second equation, our second relationship. So now we have our two equations and two unknowns. With that, we tend to look for things like substitution or factoring. What should we do here? Yeah, this is really set up well for substitution. So everywhere we see an x, in goes a minus 2y. All right, so what is that going to be giving us? Well, we're going to get minus 2y squared plus 2 times minus 2y times y plus 3y squared equals 3. These are big numbers, but that's all right. Minus 2y quantity squared. Is it 4y squared or is it negative 4y squared?
It is 4y squared.
Are you sure about that?
Yes.
Do you want to call a friend? Now I'm making you doubt. No, you're right. It is 4y squared. But I've seen people make this mistake before. When you're squaring a negative, it becomes positive. So don't forget that. On the next term, 2 times negative 2y times y, negative 4y squared. And 3y squared equals 3. Ha! Cancels. Divided by 3. Wha! So you get y squared equals 1. So what is y? Plus or minus 1. Okay, so that's leading us towards points. So really, the Lagrange multipliers, it's saying, look at these points. These are the good points. So we now know the y values are 1 and negative 1. Where do we get the x values from? Yeah, we got the substitution. So if if y is positive 1, x is negative 2 times 1, so that makes a negative 2. If y is negative 1, x is negative 2 times negative 1, so that makes a positive 2. So we're almost done, but not yet. Our last thing to finish this problem off before we move into the next topic. What do we do with these points? Plug them into f. So this is our y minus x. So y minus x, 3. Y minus x, negative 3. And then you just say, I can see 3 is a big number, and negative 3 is a small number. And that's how we get to the answer. I will say that there's sort of an interesting geometric thing going on. But that's a story for a different day. Any questions for this? If you see a Lagrange multiplier problem, are you ready? All right. Good. I believe in you.